Guys are following me now. I'm recording now. No worry. So, like I mentioned, grid line A now, we want to break grid line A into different pieces. Because if you look at the total length is around 3 meters, 6 meters, is close to 18 meters or more than that. So it will make sense for us to break it down. So now, if we start from this axis, we've already placed a column here. So let's now move to the right hand side. So if we move to the right hand side, you see that here, there is no wall here on the ground floor. There is no wall here. The next wall is like, so this column is like it's isolated. It's like it is isolated on the ground floor. So it will make sense to put another column at this corner. I hope you are following me. To put another column at this corner. So now that we've placed another column at this corner, so we cannot place a column here because this is a window side. Are you with me? So the next grid line that the architect put was at uh 3, grid line 3. And if you place a column here, this is a window side. So you cannot put a column there. So, and then from grid line 2 to 3 is 6 meters. So that means if we go beyond 3 meters, beyond grid line 6, our beam will be too long because this is already 6 meters. So if we go beyond like here, we are going to be having around maybe 8 meters. That will be too long. So it will be better if you stop just before the window. Okay, I'm just going to click random and then I will place it correctly. So if you stop just before the window, are you with me? So now we have how many columns now? We have 3 columns. So it is better that you try to follow, you place your columns where the architect put his grid lines. It's not important, but the reason is because so that you don't have too much grid line that you create. I hope you get. So now I've put my column just before the window here because grid line 3 is on the window side. I cannot put a column there. So I place the column just before that. So now let's continue. So I will copy this column again. I'll copy this column. Then I now move to the next grid line. The next grid line is grid line 4. You can see that the distance between them is around 5 meters. But the problem is, if I place a column here now, the next grid line is what? 5 meters. Is grid line 5. The distance between grid line 4 and 5 is 6.2. So the distance here is around 3 point something. So it will make sense if I put my column here instead. If I put my column here instead and remove this one, are you guys with me? So if I put the column just be after the door, I'm going to share us this file after the class. Just after the door, I put my column here. The reason why I don't want to put it on grid line 4 is because it is very short to grid line 3 and it is very long to grid line 2. So it will balance up if I just shift it just a little bit. I hope you get. So doing this,
Okay, sorry to interrupt, sir. I
okay.
think I get where I'm getting it wrong now. So it's not a must for me to follow the architect grid line
No,
for
no,
my
no,
column.
no, no, no.
So because I'm having like 7 columns on on a row, trying to follow the columns, and I see that I need another column at another point.
No, 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 you don't have to. This is just for convenience. You get convenience in the sense
Okay,
that, like now, the architect just have how many grid line here? 5 in the vertical direction. So if you
okay.
now place too much column at different points, you have to be creating different grid lines to signify those columns.
Mhm.
I hope you get now. So now this is
Yes,
it.
sir.
We finish this one now. We finish grid line A. So we now move to grid line B. So on grid line B, it is not compulsory that you use the grid line as I'm explaining it. Sometimes it depends on the shape of the building. You get. So now between grid line 1 and grid line A and B, you see that there's no wall here at all. So I cannot put any column here. The next safe place that I can put a column on grid line B is this corner. So I will move my column. So this grid line column position is the simplest. So we should try and get it. So I move my column. Then the next thing is you can see that here now, between this column and this wall, you can see that the distance is not much. But if I say, okay, it's just 3 meters, let me extend it. If I extend it, there's no wall here around. The next wall is around here. So it will be around maybe 6 meters or around 6 point something. So it will be too long. So it will make sense if I put the column at the corner here as well. Are you with me? So since I put a
Okay.
column here there's no wall at all. So I'm not going to put anything there. So I will now come to the nearest wall and put another one. So let me just put it. I'm going to align it now. So we've placed how many columns now? We've placed 2 columns. So the next column is, another thing is, when you are placing your column, be careful of the staircase regions. The staircase regions are important. For now, you see that this staircase now, look at this staircase. Okay, let me not convince us. Let us leave the staircase as if it's not there. So let's continue placing our columns. So to place your column now, the next column we want to place, we have grid line 3, but grid line 3 is very close to this column. So it will just be like a waste of money. So between grid line 3 and grid line 4 is 3.5. So that means this distance, at the end of the day, maybe it might end up 5 point something. So I can just put another column here for now. Are you with me? So if
Okay.
I put a column here, and then I put another column at the last edge here, you can see that this this column and this column, they are long. So you can just break it, even though it's 6 meters, but for economic design it will work. But for economic design, you can break it. And another reason why I wanted to break it in the sense that I will put a column at the middle, is because this place is a car garage. If I did not break it, there's no way I can divide this slab into two, maybe with a column, to reduce the load on the beam. So there will be a huge load on that beam. So because of that, let us break this column, these 2 columns, with another column at the middle. So I will just copy this and just let me just place it randomly. And then let me try to look for the midpoint of this. I want to place it to align with this wall. So what I will do is I will draw a line here and move the midpoints of the two to intersect. Okay. So this is what I have now. I hope you guys are following me.
Yes.
Okay. So another thing now, we've placed the column at grid line A and grid line B. So let us now look at the vertical distance. You know, what we do there is we are looking at the horizontal distance between the columns. They are not too much. But how about the vertical distance between the columns on grid line A and the columns on grid line B? If it is not too wide, so that we can break it. But if it is small, we don't need to break it. But if it is too wide, then we have to break it. Between grid line A and B is just 5 meters, so we can leave it. I hope you get. But if it's around like 7 meters, then you have to break, you put columns in between so as to break it, so that it will not be, the beams will not be too long. Then once we finish that, so let's now move to grid line C. So grid line C, we come here, I copy this column, and then this is a very wide window, about 3 meters. So it will make sense to put the column just after the window, just after with the window, like this. I will align it later. And then I will put another one at this junction here. So these are the columns I need. But a column is necessary in between to support this staircase at the half landing area. You see, the staircase is like this. You are coming from here. You go up like this. This is the half landing. This half landing is between the ground floor and the first floor. So you need to support it in this region with a beam. And if this column is going from the ground floor to the first floor. This column is also going from the ground floor to the first floor. All the columns that I'm placing here, my plan is they are going from the ground floor to the first floor. So I need another column here around this region here to support this staircase. So I will copy this column and then place it close to the end of the staircase. So I have this. So it will make sense if I put another column. I think we can all decide where the next column should be. So the next column will be here. And then the last column is at the corner already. I hope we are getting it.
Yes.
These are my columns now. I've placed all the columns as I wanted them. So you also notice that this garage then the distance between grid line B and C is 6.225. So you can decide to break the vertical beams between, there's going to be a beam from here to here. You can decide to break it with another column, but me, I will like to leave it like this because I don't like to have too much column like that. So this is the first step that you take. Is this clear? Did everybody understand it?
Yes.
Okay. So the next thing,
Yes, sir.
okay, if
Hello,
you have
sir.
question, please ask before we.
Okay. So, is it advisable for us that if our distance is more than 6 meters, we should have a column to break it back?
Yes, if you are designing a residential apartment and then
Okay.
you feel that maybe you will not be supervising, the reason why it is important to break it is because if it is 6 meters, your reinforcement can be 20 mm, maybe 3Y20 reinforcement. But if you are
Okay.
designing an economic design, like me now, if I have they are depending on the client, depending on the kind of design I will do for them. Like this design now, if I want to do it for a client that I know that they do the work, everything I provided, they are going to do it. This is how
Follow this.
I will
Okay.
do the GA. But if it's some client that I know they will not pay, so I will break it down in such a way that all my reinforcement is going to be 16 mm. I will not have any 20 mm. You get? Because
Okay.
when some clients see a design and they are seeing 20 mm back, they'll be like, gbese lele you. You get? So you
So,
should
it
know,
depends on the clients.
yeah, you should
That's what.
understand your clients and then know the,
Okay.
like now, let's say I don't want to call for example, now if you want to design in Lagos design, you know that there are a lot of regulations and all of that. If you provide something, there is high probability that they will follow it to the core. But let's say you're
Yeah.
building inside a village. Inside a village is such a way that the maximum reinforcement they will see in the vicinity is 16 mm. That 16 mm gun, you cannot even guarantee maybe the grade is going to be adequate. For you to now be providing 20 mm reinforcement, 25 mm reinforcement, it's going to be problem. Because number one,
Yeah.
what you are providing is not available in the market. They will sweat before they get that size of reinforcement. So some kind of design, just limit yourself to 16 mm. So if I want to do that, I will have to break all these vertical members, all these between grid line B and C, all the beams there that are around 6.2. You break it so that it will now leave around 3 meters. So if you want to do that 16 mm everything for beam and column, you should make sure that your span is not more than 4.5, 4 meters, so that at least if you provide 3Y16 or some reinforcement are required are stubborn, you can do 3 at the top, then you put 2 supporting it. I hope you get. So let's leave the columns like this. So the next thing is now to connect these columns with beams. So when you are doing this one is very simple. You just make sure that your beams are on top of the wall. Once they are on top of the wall, as much as possible, you are safe. So for the beams, I will change my color, the color of my beams. I think I have some beam here. So let me just make current. So for the beams, So you can see that the block wall runs from grid line 1 to 2 to 5 on the vertical axis on grid line A. So I will just draw it straight like that. So even though there's no block wall here, but no problem. So I have this beam. This is a beam. Then on grid line B, thank God everything is straight. This is another beam. But if it is not straight, you just follow it like the way it is, sha. You get. Then this is another beam running straight like that. Then the next thing is you connect the vertical columns together. I hope we are getting it. So this is going to be a vertical column. This is going to be a vertical columns. But if you go to grid line 2, we have column here, but there's no wall here. So what I will do is I will put a beam just between these two columns. This is one. Then here now, I will come to, let's place the beams that are going to be on the wall first. This is also going to be another beam like this. Then this is another wall that is going straight up. So I will put another beam, or let me just copy it. So this is beam connecting it. So this is another beam here. But this beam, I will terminate it here because I don't want it to be coming out of this kitchen area. So I will terminate it like this. Then I will put another column on this wall, even though this wall is not completely full normal wall, but your beam will be like that. So now that you've seen that I've connected the beams, you can see that just connecting the beams, I've divided this slab into panels, into different panels. So this is one panel, this is one panel, this is one, this is another one here. Then this garage here is another panel. This ante room is another panel. Then we now have the family lounge, the living room. That's a big panel. So this living room, do you guys understand what I just did? Hello?
Not really. Yeah, the video is kind of slow and
No, sir, I can't understand this part.
Kai. Okay. You can hear me now, ba?
yes.
Because I'm zooming in and zooming out, so the speed will not, whatever. So what I just did is I connect my columns with beams. So I start off with grid line A. So I connect everything because they are all on a straight line. I went to grid line B, I do the same. I went to grid line C, I did the same. Then for the vertical beams, I connect from along grid line 1 because we have block wall straight down. So I connect the columns with beams. Then on grid line 2, there's a wall there, but this wall does not extend to the living room. So I stop the beam on this column. So the same thing here, there's a wall here going straight down. I place it. Then there's another wall here going straight down. I place it. I hope we get now.
Yes.
So now to barricade my staircase from the living room, so I will put another beam close to here where the staircase ends. So this is another beam now. So now I've tried to divide my living room. Do we understand it to this place?
Yes.
Please, if you don't understand it, you can ask questions.
Sorry, what's the main reason for putting a barricade between the staircase and the living room? Like, is there a particular reason?
You see now, if I remove that beam, it's not really a barricade, I just use that language. So, okay, if I remove that beam, you can see that this area is very wide. You see the living room
Yes.
area, you can see it's very wide. So if you want to design it with 150 slab, it will not pass because if you look at it, it's around 6 meters by 8.7. So it will not pass. So where you can easily put a beam is the staircase region, where this staircase is. You know, if you put a beam there, it will not really affect the aesthetic. This staircase, this beam now, that's why this new beam is there. You understand?
Yes, but the beam, the second hand of the beam is not resting on the column. I think it's resting on the wall,
Which
at
second?
least towards the like
On,
this, the other part of the
on
beam.
grid
No, the
line
first
B?
one is just like the first part of the beam.
Mm.
That is the upper part. It's resting
Yes, I
on the
said on
wall.
grid line B.
Yes, 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 yes. I'm not
Okay, we
seeing
get
the.
to that. We have something we call primary beams and secondary beams. You see, when I'm doing it, I'm not just, this is not the only beam that look like that. This is another beam that look like that. See another beam that look like that. This is another beam that look like that. This one. We have what we call primary beam and secondary beam. So not all the time your column will support your beam. Sometimes beams support beams. You get beams support beams. So that is the idea I'm using here. You get. So with the introduction of this beam now, you can see that the living room size has now reduced. It has reduced from 6 by 6.6, 6 by 6 by 8.7. So it's now around 6 by 6 meters. So 6 by 6 meters, it will hardly pass deflection check. So it will make sense if you divide it once again. So looking at the living room, to divide it now, where do you think it will make sense to place the beam?
B and C.
B and C.
Is it column or beam?
No, you cannot put a column inside the living room now. I'm talking about beams. It's a beam that you can put.
Okay, that should be in between grid line 2 and TV, if I'm not
Okay.
mistaken.
So what we can do is, another thing is you should know is that, so with all these finishes that we do nowadays, so if you have a beam, you place it in a sitting room with all this POP, all this stuff that they do now, it will cover up all those beams extension out of the slab. So it's not a problem.
So I have a question.
Okay.
I thought the slab should cover the beam. Like whenever we are to design for the beam, there's always a room for uh the slab. Like whenever we are to cast, like the slab will cover the beam, so it will not show like the video. The video will not. We won't see the beam.
Uh, I don't understand you. Your beam is 250, 450. Your slab is 150. So for it to not show, that is why we are placing it on top of the wall. But now in the living room now, there's no wall there. And we have to divide that panel so that, like now, if like this is what I'm saying, if your client have money now, you can make this panel 150, 175, and just leave it like that. But you know the economy of the of the economy nowadays, so it will be difficult. So it will be better if you do the conventional or expected design. I mean what the artisan will be expecting. So 150 thickness of slab, that's what they will be expecting. So because of that, we are going to extend this beam down. So we extend this
Sorry for
beam down.
interrupting, sir. Hello, sir.
Yes, I'm with you.
So with your explanation now, my my beam can rest on my, let me say, on my slab
No, beam cannot
without
rest on
a
slab. Oh.
color supporting it in the other side,
Beam
because like this.
beam rest on beam, not on slab.
Okay,
Beam rest on beam. I
rest
have
on beam.
a lot of
Okay,
examples.
but okay. I got it now.
When
Okay.
you proceed in the class, you know what you just watch now is the GA. When we start modeling it, I explained extensively the primary beam and the secondary beam. That's when you understand how beam support beams. I don't want to be making repetition. When you watch the next phase of the class, you are going to get it better. So because of that, we don't want this slab to be too wide. So we break it with this beam, this vertical beam. So we are going to do the same to the car garage side too. So I'm going to copy this beam and then copy it from this column center and place it here. Do we get it up to this place?
Yeah,
Sorry, please,
but
I have a question. Sorry.
Yes.
So please, as regards the beam,
Mm,
you said for us to now have a reinforcement that is greater than that is about 20 mm in size.
mm,
So the beam that is
mm,
you're suggesting that you should have the beam like the length of like the width and the height,
mm,
all I call this. That is the distance for the beam
mm.
now. Like we should not have a distance that is about 26 meters and above.
Yes.
For us to now have a reinforcement that is very high, like
Yes.
20 mm and the like.
Yes.
So for us to have for us to have a beam, for us to have enforcement that is maybe around 16 mm or
Mm,
below.
mm,
So does it mean that both the span of the beam should not
mm.
be greater than 4.5 or around 4 should be around 4 meters, both the length
Yeah,
and
it's the column
the
that the
span
column
on both
spacing
sides?
that will determine the length of of the beams. So we are saying the same thing. So the distance between the column should not be too wide, should not be too much. So if the distance between the column is not too much, that will also dictate the span of the beam. You get?
Yes, yes, yes. Okay,
Okay.
okay, okay, okay.
so my
That is on both the X and Y axis.
Yes, yes. On both X and Y.
my 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 question is it a must like that our beam should shoot out?
No, it's not a must. I think we've discussed this in the previous class now. It's not a must. Like this
Like
example we are working on now, we have a cantilever slab. We are going to see it. That's why I picked this example.
no, what I'm saying, so in a like in a void area where there is no
I know
block
if it
wall.
is a void, you try as much as possible not to have your beam. It will not make sense now. You have a void and then you have a beam running across it. No, now.
And yes, yeah, but if the architect insists like it doesn't want because you mentioned something about like the new design like POP, maybe
Mm,
I don't know, or maybe POP is not involved.
mm.
And what other means can someone bring in place to make
Okay.
sure to reduce the span of the area?
I did not get you. Okay, what you are saying is if the panel is too wide, and
Yes,
then you don't want to introduce a beam due to maybe there's no
yes,
like in terms of maybe you are designing for, let's say, a mosque or a very open space. In that
yes,
kind of situation, most of the time, for example, now, if you are designing for a shopping mall, there's no how you want to hide the beams. You can go to any shopping mall and just look around. You will see beams. But if you want to do how will I put it, a strict design that you don't want to see any columns, any beam, it is not a problem. It's just going to chop material. Like for example, this living room now, or this garage, if I decide to remove this beam completely, you see that that area is wide, 6 meter by 6 meter, along the X, along the Y, 6 meters. But if I design it like this, 150 mm will not pass in terms of thickness of the slab. If your client can pay, no problem, you can do it. You get? All what you are saying that it should not be more than is just we are just looking at the economic part. It's not that technically it will not work. Are you getting me?
okay,
Technically, anything is possible. You can have a cantilever of 5 meters. If they have the money, they can put the reinforcements and they can cast the concrete, no problem. But our design should be economical and should be also be safe. So that's why the money is let me just say is the number one factor sef. After safety, the next thing is economic. So that's why you see a lot of collapse building because people are trying as much as possible not to spend money. You get? So that's why as the designer, you need to understand the kind of client you are working with. You get? So it's important.
Okay.
Do we all understand it to this point? Because this is where most of us used to get it. What most of us used to miss it, especially those guys that send me their this thing. The next thing we want to do now is where we miss it. Do we understand it to this point?
Yes.
Yes, sir. Understood. Understood.
So now let us
Sorry,
pay
sir, please, I
attention
don't know.
now.
Sorry.
This everything
Sorry,
I
sir.
did there. You want to ask something?
I want to ask about that secondary and primary beams.
I don't want to explain all those things now. Everything is inside the class. Deeply explained with a lot of example. So you will see it in the class. So now that we understand that now, the next thing is what we want to do is we want to support, the ground floor is on the ground. This ground floor that we are placing our column and we are putting on the beam on the wall is on the ground. That is not what we want to support. What we want to support is the first floor. That's why we call it first floor GA or first floor layout. If you say second floor layout, what we are saying is we want to support the second slab. I hope we get. So now all these columns, they are coming from the ground. This is what they actually wanted to support, this first floor. Are we getting it? So
Okay.
now, you want to say something?
No. You can continue.
Okay, so now what we do is we now copy our columns and beam that we already have on the first floor and now paste it on that we already have on the ground floor and now paste it on the first floor. This thing is not compulsory. The reason why we are doing it is that so that we're able to see everything that is going on. Let's say we are doing the GA on paper. There's no way you can, before what we used to do before is we do it on paper. You have your ground floor like this, you have your first floor like this. You place your column, then you now start tracing it. So that is really stressful, but because of AutoCAD, we can now do a lot of things easily. We get. So you copy the columns and the beams. So what I'm going to do is I have a lot of column and beam here. So I want to isolate these two plans. So isolate. So I've isolated them. So I will click on the beam and also the columns. Then I right click and select similar. I've copied everything. That's why it's good if you are working with layers. You create layers for every item you want to do so that you're able to maneuver around. You get. So now that I've done that, the next thing I want to do is I will now copy it from a known grid line. I'm not just going to copy anyhow. I will copy it from a known grid line. So let me copy from grid line 1, A.